Alright, so I got my part, I got 4 pieces of shim stock, and I've roughly adjusted my jaw opening to, well, it'll definitely allow my shim stock, and I didn't want to have an excessive amount. Now while I'm doing this, I will never leave the chuck wrench in the chuck. That's unexcusable. What I'm going to do is just pay attention to where I'm applying pressure against the shims, and I'll use my fingers to stabilize them, while with the other hand I'm operating the chuck wrench, but never letting go of it. So of course I can easily put that shim in, and then slide this one into place. Then I'll come down, and it just lightly made contact and I stopped. Now I'll slide in my other 2 shims. And the reason I'm using shims instead of a collet is we don't have a collet that opens up to 1.5 inches. So there you have it. Just be patient, think about what you're doing. There's no excuse for leaving a chuck wrench in a chuck. I just got all the shims in. Now I can put my indicator against my part and I can dial it in. And I can also check the face of the part, and I can give it little taps with probably an aluminum rod and a hammer to tweak it so the face doesn't have a bunch of run out. Okay, so this is what I was just talking about. I have the part, it's pretty close to dialed in, the jaws are definitely not too tight, and I put the indicator over here on this surface, and when I rotate the chuck, we see the run out reading. Now, right now, the lowest reading, which is what we're at, tells me the part is like this. So that means if I drive down, it'll re-square it up, and then it'll run true. If I set my aluminum rod here, hit this in with a ball peen hammer, I'm hoping to get the movement I want. However, it's not a great idea to bounce an indicator. So if I'm striking here and my indicator starts bouncing away, that can damage it. So maybe I'll roll it away and give it a love tap and then bring it back in, spin it, and see what it's doing. And I usually strike from straight on, but with the camera, it's kind of in the way. Now I'm going to spin the indicator back around and finish dialing in this surface. And if it was actually an important part and it needed to run true concentricity wise and perpendicularity wise to the centerline axis, I would go back and forth with test indicators until it was perfect. But this is a screw jack, so we're not going to do that. We're going to get it within a thousandths, call it good. Okay, so that's in frame. We'll give this a spin. Okay, so like I said, it wasn't perfectly dialed in. It was closer, but when I moved it, it obviously changed the reading I was getting here. So I'm going to stop. That's my furthest counterclockwise position. I'm going to zero my dial. Then I'm going to go to the opposite jaw, and I see I'm on, we're going to call that 22.5. So if I rotate this back to, we'll call it 11. Then I know that that zero is my aiming point. So if I start to snug up my jaws, I got to +5. When I go back here, I should be about -5, which I'm close. So we're minus, let's say 2. We're plus about 1. I went a little bit too far, darn it. Is that in frame? Yeah, that's pretty good. So we're 0. Over here, we're basically 0. On this one now, these other two jaws, I just aim for the same spot. So that's 0. 0. And I'm gonna have a heck of a time tightening this up with the tripod blocking me. That's good there. Good there. Yes. All right. Okay, everything's tight enough. It's secure. Now let's just see what happened for fun with the face of this part. How true it is or isn't. If it's less than 3 thousandths, we ain't touching it. Actually, I'll roll it up here. That in frame? Pretty much. Oh no. All right, 2. So, yeah, I could try to beat it around, but I'm not gonna. I'm gonna put a boring bar in here. I'm gonna face out with the boring bar till I get my correct overall length, and then I'm gonna bore in the 1/4 inch depth for the counter bore. All right, you notice I didn't make layout lines. What I did was I just measured the part's overall length and then subtracted the finished length from the current size. And my plan is I'm going to turn on the spindle, touch off on the face of the part, and then 0 the Z-axis on the readout. And then I'll be able to just take 3 passes to get me my 50 thousandths of extra material off the part, which will put me at my finished length. At that point, I'm going to go into the center of the bore, put the boring bar in 1/8 of an inch, and then I'm going to back the tool out till I touch off on the inside diameter of the hole. As soon as I do that, I'm going to bring the tool out of the bore, and I'm going to adjust back by 100 thousandths with the cross slide. That's on the diameter, and then I'm going to hand feed into my 1/4 inch depth from the end of my part. And from there, it'll just be a few cuts, and I will have went from my 15/16 hole out to my 1 1/4 inch diameter, 1/4 inch depth counter bore. Take a quick measurement, make sure everything's doing what I think it is. And it's looking good. Okay, and I only went 50 thousandths. I think I said I will dial 100 on the diameter. I went in I dialed out 25 per side or 50. If I said 100, I didn't mean it. All right, so I'm at 997. Now before I take my last cut, I should probably check. I should be at 1.2, maybe 1.202, we'll see. .201. Yeah, so we're at 1 inch 201. And on the last pass, I'm gonna go in, and then I'm gonna face out. And that's going to actually ensure that my wall is perfectly square and it doesn't have a bunch of jagged edges, because the insert has relief on the front cutting face as well as the side cutting face, of course. And I have been stopping at 1 inch 248 instead of 1 inch 250, so that way I did leave myself 2 thousandths to clean. Now what we have to do is break that edge, and then also we're going to break the edge of the threaded section and the counter bore. So I think you can see the chip, and like I said, I just very lightly broke that corner. I don't think you're going to be able to see when I chamfer the threaded section, but maybe if I move the camera. Now when I'm doing that, I'm backing the cross slide out while I'm moving back and forth. So the further back the cross slide is, moves the tool position, which in a way it moves the cutter in more, but it's really not. It's moving it out. It's a lot finer adjustment method than using the carriage. So I say you should probably use the cross slide to make your fine adjustments. But let's do the outside chamfer, and then this part is done. Lightly touch. Okay, so that was after my touch. That was 62 thousandths off the diameter that I went in. And if I hold up my ruler here, you can see, or maybe you can't. Actually, hold on. I'll hold it up on the 16th side. That we're only at 30 seconds, so we're only halfway there. All right, let's do a quick inspection of our base piece here. On the knurled section, 1.5 there, 497. On the 1 5/8 section, yeah, 623, not bad. Inside the groove here, about 379. Overall length, I actually ended up getting a little shorter than I wanted, 306. So I touched off a little harder than I should have, or I measured over a burr, not sure. 312 was the target. We're still inside tolerance. 1 1/4 on the nose. .251 on the depth, and 940 after the tap ran through the hole. It was probably 937. And you can see maybe very, very lightly broke that edge, and then we have a nice lead for the thread to start, and good looking threads. And the knurling's pretty good. Kind of a weird spot there. That might have been when I was coming back in after my knurling tool issues, but yeah. Work safe.